Hi everyone. In this video, we are going to go over the answer key for problem set 9. Problem set 9 covers the idea of two sample hypothesis testing. So whereas last week we covered one sample hypothesis testing, and as a brief reminder, one sample is where we have one group versus the entire population. Two sample hypothesis testing is where we pose two groups against one another. So one group against another group. And so with that being said, let's take a look at question number 1. Half of the inmates at the St. Louis County Jail receive an anger management program, while the other half do not. And so right off the bat here, we see our two individual groups, one that received an anger management program and the other that did not. And so whereas a one sample test would have been one group versus an entire population, we already have established our two individual groups. That'll be important for problem set 10 and for your final quiz when I'm not going to be able to tell you if it's one sample or two sample. So just keep that in mind as you move forward here, that in the back of your head, you're going to have to establish whether it's one sample or two sample on your own. So let's go ahead and read the rest here. 2 months later, the jail records the number of misconduct violations to measure the effectiveness of the program. Did participation in the anger management program result in significantly less misconduct violations at an alpha level of 0.01? You must complete the 5-step model of hypothesis testing and show your work to receive full credit, and please round your Z obtained value to the hundredth place. And so a couple of things here we want to establish right off the bat. As I mentioned in the very first sentence here, we know we are obviously conducting a two-sample test here. We know that because that's what problem set 9 is covering. But again, we could establish that straight from the first sentence simply because we have two distinct groups or two samples in this case. The second thing we want to note as well is whether or not we are working with proportions or with means. And so let's take a look back at our question here and figure out which one we're using. And so within the context of this problem, I see that we have a table here, and I see that we have a designation here of P, which I know stands for proportion. And I see a proportion value here for group 1 under anger management of 0.24. And for group 2, with our non-anger management group, I see 0.34 as well. And so moving forward, I know right off the bat, and I see it highlighted here in our answer key, that we will be conducting a two-sample hypothesis test for proportions. And so with both of those pieces of information, knowing that it's a two-sample test and for proportions, we can now proceed with step 1, which is stating our assumptions. And the reason why we have to establish that this is the test we will be conducting first is because our assumptions are dependent on what test we are conducting. And so with that being said, let's take a look at what assumptions we have to make for a two-sample hypothesis test for proportion. The first thing is, and this is consistent across all of our different types of hypothesis testing, is that we are working with independent random samples. And for this case, we know that these are distinct and independent of each other because you either participated in the anger management program or you did not. So we have that one checked off here. The second is that the variable we are testing is nominal. And so in this case, we always think about nominal variables, or at least I like to, as if you did something or you didn't. And so think all the way back to chapter 1. That was our yes or no variables oftentimes, right? You can name something. It doesn't have a numeric value attached to it. And so this case, you're either in the anger management program, you did it, yes, or you didn't, no, right? So it's just two distinct categories here. There's no numeric value between those. So we have another check mark there. We're good on assumption number 2. And finally, and this is what changes between one sample tests and two sample tests. Now we have to ensure that both of our groups or both of our sample sizes exceed a value of 50. So now you see that because N1, so meaning our sample size for our first group, and N2, or the sample size of our second group, exceed a value of 50, the sampling distribution will be normal. So we have to make sure that both are. I see back in our table here that our group size or our sample size is 300 for both groups. So we're good there as well. So all of our assumptions have been met. We can have 3 check marks there. And so I know I am good to go to proceed to step 2 and with the remainder of my steps for our 5-step model. And so let's take a look at step number 2, which is where we are going to state our hypotheses. Remember that we have to do this in statistical notation. Again, it's perfectly fine if you want to also write these out, if it's helpful for you to kind of visualize this, but the statistical notation is the requirement. And so you can also write it out, but you also have to have the statistical notation. So let's take a look here. Because we are working with proportions, our population parameter designation for population parameters is our pi symbol here. And so if you like to think about this in terms of groups, you could write anger management. And for our null hypothesis or our statement of no difference, we always show this with our equal sign. And so we could say that our population proportion of anger management is equal to our population proportion of our non-anger management group. Or in other words, you could also show this with pi 1 equals pi 2, right? Group 1 versus group 2. Our alternative hypothesis or our research hypothesis is going to be dependent on what our question states or what are we interested in testing here. And to know that, we have to look back at the context of the question. So let's see what our research question is actually asking us. So, did participation in the anger management program result in significantly less misconduct violations at an alpha level of 0.01? And so this is where you need to make sure that your research hypothesis symbol matches what the question is actually answering or asking you to answer in this case. And so we have our less than symbol here. And so those two have to connect here. And we'll also revisit this in step 5 at the very end. So consistency throughout all of these steps here. Make sure that they all align together. And so this is what you should have. Only what's necessary is here right on the tail end. And make sure that you have for your null hypothesis here, H0 to designate your null, and either H1 or HA for your alternative or research hypothesis as well. Moving on to step 3, we know that we have a 2-sample test for proportions. We established that right off the bat, so we knew what assumptions to make. So we know that we will be running a z-test. We also know from the problem itself that this is an alpha level of 0.01. We also know based on the alternative hypothesis we just made here in step 2 that this is a one-tailed test because we are only interested in whether or not it is significantly less misconduct violations. And so what that means is visualize our normal distribution here. We're only interested in one tail of that normal distribution. If the question would have stated if it was different, then we could have worried about both ends of the distribution, and that would have been a 2-tailed test. But because we specified a direction, we only care about one-tailed. And so now knowing both of those pieces of information, both our alpha level of 0.01 and that it's a one-tailed test, we can now go to our chart and check off that we have a z critical value now of negative 2.33. And we know that this is negative because it specifies that is significantly less. So we know it's on the negative end of our distribution. If it would have said significantly more, then it would have been positive 2.33. So either way. Now we can proceed to step 4, which is actually computing our test statistic. Based on the problem, we know the following information, and I'm taking this straight from the table that is provided to us. Here I have listed our 2-sample test for proportions base formula. And so what you see in the next following steps here is me simply working through the math based on the information that I have gathered from the actual table itself. And so here, this is a good time to check your work against it if you had any issues computing this specific z obtained value. And you should get approximately negative 3.75 as your z obtained value. And so with those pieces of information in mind, taking together from step 3 that we know our critical value is negative 2.33. We can plot this out now in step 5. Again, I always like to visualize it because it makes it a lot easier to see whether or not we are falling into our rejection zone or if we're safe in our fail to reject zone. So let's take a look at what our final outcome is here. Again, biggest part of step 5, though, is making sure that we are interpreting this result within the context of the problem. It is not enough to simply just say we are rejecting the null hypothesis. Because if these individuals were actually asking us as researchers what result we came to, and you just went and told a police officer or a correctional officer that we rejected the null hypothesis, what would they take away from that, right? We have to actually substantively tell them what that meant in the context of the research question that they wanted more information on. And so, with that being said, for this example, they wanted to know whether or not their anger management program actually had any effect on misconduct violations. And so, we have to be able to contextualize with our results and our statistical analysis what that actually meant. So in this case, we could state something along the lines of, and again, this is just an example interpretation, that given our z obtained value of negative 3.75, and it falls beyond our critical region of negative 2.33, we reject the null hypothesis. Again, we fell into our shaded region here. We are beyond that critical point. We conclude that participation in the anger management program resulted in significantly less misconduct violations than the non-anger management group. So in other words, it did look like it was successful, right? The anger management program resulted in less misconduct violations among those individuals that participated in it. So again, that's helpful information for those individuals to know that are running that program, right? If we would have failed to reject the null hypothesis, then maybe they wouldn't have invested more into that programming because it wouldn't have been effective, right? So why pour more resources into it if it's not actually achieving the outcome you want it to? And so with that in mind, that is our result for question number 1. So let's take a look at our second question here. Okay, question number 2. A random sample of felony cases shows that defendants convicted at trial with N170 receive an average sentence of 26.7 months with a population standard deviation of 5.8 months. In comparison, defendants who plead guilty with an N of 195 receive an average sentence of 22.9 months with a population standard deviation of 4.6 months. Do defendants who take their cases to trial receive significantly longer sentences than defendants who plead guilty at an alpha level of 0.05? You must complete the 5-step model of hypothesis testing and show your work to receive full credit, and please round your z obtained value to the 100th place. So again, the first decision we need to make here and what you would be doing in the context of problem set 10 for this week and for your final quiz is determining what type of test you should be conducting. Obviously, for problem set 9, we know that it's a 2-sample test, but we still have to determine whether or not it's for means or for proportions. And so in our very first sentence, we have a few clues for us here. And I see right off the bat that we have a key term here, which is average sentence, right? Average is basically just a synonym for mean. And so I know that I will be conducting a test for 2 sample tests for means. I also see here that I have 2 distinct groups, defendants who plead guilty and defendants who take their case to trial. I'm not comparing either of those groups to a national population. And so it's not just one group versus a big population. which would have made it a one sample hypothesis test. And so I do have those two distinct groups here. And so that could have clued you in had I not told you already that it was a two sample test for you to know if this were to be presented to you in the context of an upcoming quiz. But now that we know that that's the type of test we would be conducting, let's take a look at what our assumptions would be in step 1 for this type of test. So for stating our assumptions, just as we do for all of our hypothesis tests, the first thing is that we are working with independent random samples. Again, we know we have two distinct groups here, right? Those who plead guilty and those who take their cases to trial. You cannot do both of those things at the same time. You can only do one or the other. You can't both plead guilty and take your case to trial. You can't also take your case to trial and plead guilty, right? Those are mutually exclusive from one another. So we're good to go there. The variable we are testing is interval ratio. Here I see that we have an average sentence length, right? And it's measured in months. And so this is something measurable that has discrete intervals in between them. So it's numeric and we can measure it in between it to have a scale. So we're good to go there. We know that it's interval ratio. And we just need to check our sample size for each individual group. So first we need to take a look at those that were convicted at trial. So I see that that group is 170. Good to go there. We're above 50. And the second is those that pled guilty. So 195, so well over 50 as well. We're good to go on our third assumption. And what you might notice here in comparison to question number 1 is that we have a fourth assumption that is unique to two sample tests for means specifically. And so not for proportions, but only for two sample tests for means. So if you miss this, this is a good time to write this down, note it moving forward. And this assumption is that the population variances are equal. This isn't something that you would necessarily see within the context of the question itself. It is an assumption and it is based on the normality of the curve of our normal distribution. And so as long as we see that we're pretty good for step number 3 and that we're not violating that assumption, we're pretty set to go for step 4. And so there's no real issues there. Again, we still have to state it as one of our assumptions, but there isn't any violation occurring here as long as we're set to go with our third assumption about our normality of our sampling distribution. And so we got 4 check marks there. And so let's proceed to our statement of our hypotheses in step number 2. Again, we're doing this in statistical notation. First off, with our null hypothesis, I have H with a subscript of 0. Now you'll see that our statistical notation has changed now that we are using means. Whereas with proportions, we were using the pi symbol. Now our population parameter for means switches to mu, which is basically a fancy U, right? It's a Greek symbol. And so I have our statement of no difference for our null. So again, we are using the equal symbol to designate that. You can either say it in plain language, so our group of those who pled guilty against those who went to trial. You can also just say that with mu group 1 equals mu of group 2. So either of these are acceptable. And here I need to check the context of the problem to see what direction, if any, we are testing our research question. So let's see what we're taking a look at here. Do defendants who take their cases to trial receive significantly longer sentences than defendants who plead guilty at an alpha level of 0.05? And so in this case, our keyword here is longer. And so we are actually switching our symbol direction from question 1, whereas question 1 asked about significantly less than, now we're switching it to longer. So now I have the greater than sign. So that's what you see here in my research hypothesis. And just as a side note as well, keeping our consistency with our alternative or research hypothesis, you'll see my H1 here at the beginning as well. And so just double check here that you have the correct statistical notation. This should look very consistent for you as you move forward with any sort of hypothesis testing. Just keep in mind that your population parameter symbol will switch between our pi symbol and mu symbol, depending on whether or not we are working with proportions or for means. Let's go ahead and go forward with step number 3. Selecting our sampling distribution. This is a 2-sample test for means, as we established right off the bat. So we will be performing a z-test. Because we have a direction specified, we just established in our alternative hypothesis that we are interested in whether or not they receive significantly longer sentences. We know that this is a one-tailed test. But unlike question 1, where we only cared about the negative end of the distribution, now we only care about the positive end of the distribution. So, because we know that it's a one-tailed test and it was specified within the question that we are going to be using an alpha level of 0.05, we can now reference our chart and figure out that our z critical value is 1.65. So again, I don't expect you to memorize those values. Simply just look at your chart, and that's where it matches up with both of those pieces of information in mind. So now we can go ahead with step 4 and compute our test statistic. There's a lot of information that we actually need to know for a 2-sample hypothesis test for means, but all of this can come from the question itself. We just have to scroll up a little bit here and make sure that we note it here below. So we need the average sentence length from each individual group. So I have 26.7 here for group number 1, 22.9 for group number 2, and also the population standard deviation from each respective group as well. I have those listed below. And then our sample size for each group as well. Here is our base formula for our 2-sample test for means, in which our population standard deviation is known, and it is in this case. Again, if you had any computation issues with your test statistics, or in other words, your z obtained, please take a look at each of these steps below for any potential calculation errors so you could see that. Your z obtained should be approximately 6.86. And so with that in mind, let's take a look at what decision we should make. Again, I always like to plot this out. We have a one-tailed test in the positive direction of our normal distribution. Again, we're only interested in whether or not this was significantly greater than, or if those who receive a significantly longer sentence length. So we have our one-tailed test here. Our z critical value that we established in step 3 was 1.65. So we know that our z obtained value that we just calculated in step 4 was well beyond that cutoff value, right? We're way at that end of the normal distribution here, many standard deviations above. So we fell again into this rejection zone. So what does that mean though within the context of the problem? How are we interpreting this? Let's take a look at how we would respond to this for our judges and these sentence lengths. So an example interpretation here could be, given that our z obtained of 6.86 falls beyond our critical region of 1.65, we reject the null hypothesis and conclude that defendants who are convicted at trial receive on average, again referencing back to the point that this is about means, on average receive longer sentence lengths compared to defendants who plead guilty. This is actually a studied phenomenon known as the trial tax. And so researchers have actually looked into this and have shown in various studies that defendants who do take their cases to trial are often punished for doing so. And on the tail end of their trial, do receive longer sentences than individuals who do plea bargain and take a plea prior to taking it to trial. And so that was an example of what I was trying to illustrate here. And if you're interested in more about that phenomenon, please go ahead and research that. Again, it's called the trial tax. Okay, let's take a look at our very last question here. Question 3. A statewide judicial council wants to examine whether participation in a judicial decision-making workshop influences judges' sentencing practices. The workshop aimed to educate judges that minor drug possession charges should not automatically shape their perceptions of a defendant's prior criminal history. After the workshop concluded, 150 district court judges were surveyed about whether they considered prior marijuana possession convictions when imposing new sentences. Of these judges, 80 attended the workshop and 70 did not. Among those who attended, 43 reported considering prior marijuana possession convictions, while 44 of the non-attendees reported doing so. Do judges who attended the workshop differ significantly from those who did not in their likelihood of considering prior marijuana possession convictions during sentencing at an alpha level of 0.1? You must complete the 5-step model of hypothesis testing and show your work to receive full credit. Please round your z-obtain value to the 100th place. So again, because this is problem set 9, we know that this is a 2-sample test, but if we didn't know that in the context of a problem set 10 or your final quiz, we know that this is a 2-sample because we have 2 distinct groups, those judges that attended the workshop and those who did not. And so with that in mind, let's figure out if this is going to be a test for means or for proportions. We know that we can easily calculate a proportion if we have a certain segment of judges who have done something, and we know the total of those as well. So we see here that we know how many judges attended the workshop and how many did not. And so we know that 80 did and 70 did not, and we know how many reported considering prior marijuana possession convictions after they attended and how many considered doing so after they didn't actually attend the training. And so we can easily convert that into a proportion value. You see that I did this within our little table here to help you visualize that as well, with both our p-values for proportion and our n values for our sample size here as well. And so I know that this is going to be a 2-sample hypothesis test for proportions. And so with that in mind, we are actually going to have the exact same assumptions that we did for our very first question. But as a brief reminder, they are that we are working with independent random samples, just as we do for all of our hypothesis testing assumptions here. The variable we are testing is nominal. Again, whether you attended the workshop or not, it's a yes or no binary category. And because both of our sample sizes for our group 1 and group 2 exceed a sample size of 50, the sampling distribution will be normal. I see here in group 1 that I have a sample size of 80, and in group 2 I have a sample size of 70, so we're good there. Can check off each of our 3 assumptions here, and we're good to go to proceed with conducting each of our additional steps. In terms of step 2, we need to state our hypotheses within statistical notation. Here I see that we are back to using our pi symbol because that is the population parameter we use to designate proportion values. So here I see that our null hypothesis symbol has not changed. We are always using that equal sign. So I have our pi symbol of 1 equals our pi symbol of 2. So group 1 equals group 2. No difference there. Here, though, I see that our key here in our research question is, do judges who attended the workshop differ significantly from those who did not in their likelihood of considering prior marijuana possession convictions during sentencing? So here, our key word is differ significantly. In comparison to both question 1 and question 2, who specified an actual direction, one was lower than or less than, and one was higher or longer than, here it just says difference. And so that's our key to know that we are actually interested in both ends of our normal distribution. We're not necessarily hypothesizing whether it could be in either direction, right? And so we know right off the bat, simply from looking at our step 2 here, and this will help us for step 3 here in a second, that this is going to be a two-tailed test. And we know this because our symbol here is going to be our not equal to sign because we're not specifying a direction. And so that's why we are choosing that here rather than a less than sign or a greater than sign. Step 3, selecting our sampling distribution. It is a two-sample test for proportions, so a z-test once again. Our question specified an alpha level of 0.1. And as we just mentioned in step number 2, this is a two-tailed test because it is asking about a difference rather than a specific direction. And so with those two pieces of information, knowing that is an alpha cutoff of 0.1 and a two-tailed test, again, just reference your chart here, our z critical values on both ends of our normal distribution are going to be 1.65, but both positive 1.65 and negative 1.65. So keep that in mind. It's our boundary points on both ends of the distribution. Once I scroll down here in just a second to our visualization, that'll make a little bit more sense, but just hold on to that for 1 second. So with that in mind, let's go ahead to step 4 to our computation of our test statistic or our z obtained. So based on the problem, we know the following. The proportion of our first group, so how many judges did consider this following those that attended the training. Then we have the proportion of judges who did not attend the training still consider this. And then the sample size of each respective group. Again, if you had any computation errors that I may have noted in Canvas, if you received individual feedback, please reference that here. If there were any little errors along the way, again, I worked through it step by step here, so you can see if there were anything, again, that might have been minor. You should receive a z obtained value of approximately negative 1.14. And so with that in mind, again, here, this is where we are visualizing our normal distribution with a two-tailed test. And so unlike question 1 and 2, where you only saw one shaded region on either side of the distribution, here you're seeing two shaded regions on both ends of our distribution. You see our negative 1.65 on the negative end of our distribution, and a positive 1.65 on our positive end of the distribution. And so, knowing that our z obtained from step 4 is negative 1.14, where does that leave us with respect to our normal distribution here? Well, we fell right here in our safety zone, right? We didn't fall into either of our shaded regions, right? We're right here in the middle in our white failed to reject zone. But what does this actually mean for our judges and those who attended this training, right? We have to report back about whether this training had its intended purpose. Did it accomplish what the trainers wanted it to? So in this case, let's contextualize that in our interpretation. Given that our z obtained of negative 1.14 does not fall beyond our critical region of plus or minus 1.65, we fail to reject the null hypothesis. Let me write that a little clearer here. We fail to reject the null, little typo there. And this is very specific language. I want to make this point clear. We don't accept the null hypothesis here, and we don't not reject the null hypothesis. I know those substantively mean similar things, but in hypothesis testing, we really only have two choices here. We either reject the null hypothesis or we fail to reject the null hypothesis. So just don't reinvent the wheel here. Just keep those two central ideas in mind. It's really only those two options. And because we failed to reject the null hypothesis, we then conclude that judges who attended the workshop do not significantly differ in their likelihood of considering prior marijuana possession convictions in sentencing compared to those judges that did not attend the training. And so even when we scroll up here, we can see that the proportion values are slightly different between those two groups, right? It is a little bit less for those judges who did attend the training, but it's not statistically significantly different. And so what that means substantively is that it's still up to random chance at the end of the day. There's not enough of a difference that we can confidently say as statisticians that it's such a big difference that it was up to the program itself that caused that difference. It's not a big enough one that we could say that for both questions 1 and 2. And so even though there's a little bit of a difference here, it's not big enough that we could confidently say that it was the program itself that may have been the actual influence on these judges. And so that is something that we could report back to those individuals that did that training. And they could then use that information to either go back and maybe rework some of the training materials that they may have implemented, or kind of rework how they might approach that in the future, right? Maybe a type of training like that isn't the most effective, or maybe if it was a virtual training, they may want to bring it in person so that they can connect better with the judges, right? So these are different types of applications where we can use statistics to inform different policy initiatives or training initiatives to really help elevate different criminal justice initiatives. And so, with that in mind, if you had any issues with this problem set and our two sample hypothesis, different types of problems here, and especially if this was more difficult for you in comparison to our one sample hypothesis testing, please let me know. As I've mentioned before, problem set 10 is going to cover a mix of both one sample and two sample tests, and I will not specify whether or not they're one sample or two sample. Again, as a brief reminder, one sample hypothesis tests is one group compared to an entire population, and two sample hypothesis testing is one group versus another group. And so that's where you can kind of make that decision right off the bat. And that should be your first decision before proceeding with any of the other steps. Don't jump into step 1 without making that decision first, because again, your assumptions are going to depend on what type of test you're conducting. So there's no point in making those assumptions before you establish what type of test you will be conducting the rest of the way through. And so if you do have any questions about this, I fully recognize, again, hypothesis testing is by far the most complicated and very specified type of unit and information we have in this class. It is a lot of critical thinking, but again, it's kind of all of the information that we've done up to this point all together, right? We're bringing in information all the way back from chapter 1, where we discuss the difference between different levels of measurement, nominal variables and interval ratio variables, right? That's all the way in our assumptions in step 1. We talked about the normal distribution in chapter 5. So we're bringing together all of these ideas to actually now be able to conduct statistical analysis. But it is tough stuff, and I do recognize that. So if you are still having difficulty with this, please send me an email, stop by my drop-in hours, or email me to set up an appointment. And as always, I will see you in the next video.